Welcome to Math 9 class with Mom MC, Mom Forts, and Sir Reynold. So today, I will be discussing variations. So the objective of this discussion is the learner illustrates situation that involve the following variations. First, direct variation. Second, inverse variation. Third, joint variation. And lastly, we have the combined variation. Variation is defined by any change in some quantity due to change in another. We often come across with different types of variation problems in mathematics. Variation problems involve fairly simple relationships or formulas involving one variable being equal to one term. Now, there are four types of variation. First, we have the direct variation. Now, there is direct variation whenever a situation produces pairs of numbers in which their ratio is constant. So, I will be discussing further these types of variation later on. Now, on the inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. So here in direct variation, the ratio is constant, while on the inverse variation, product is constant. And then joint variation is closely the same with direct variation. Only joint variation involves three or more variables rather. And of course, combined variation. So it is a combination of both the direct and the inverse variation, or it can also be a combination of joint variation and inverse variation. Now, direct variation. Again, there is a direct variation whenever a situation produces pairs of numbers in which the ratio is constant. So, for two quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. So, whatever happens to the first variable, the same thing will happen to the second variable. So, if the first variable increases, the second variable will also increase. And likewise, if the first variable decreases, the other variable will also decrease. So, that is for your direct variation. So there are situations in real life which illustrates direct variations. Both variables in the situation produces the same changes. Let us have an example. The SSG of Tibao National High School launches a recycling campaign of waste materials to raise learners' awareness of environmental protection and the effects of climate change. This is in connection with the celebration of Earth Month. Every kilogram of waste material earns points that can be exchanged for school supplies. Paper, which is the number one waste collected, earns 6 points for every kilo. Now, the table below shows the points earned by grade 9 class for every number of kilograms of waste paper collected. So, on the first column, or in the first row rather, we have the number of kilograms, which is represented by letter N. So we have 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, and 5 kilograms. On the second row, we have the number of points earned by the grade 9 class. So upon collecting 1 kilogram of waste paper, they have earned 6 points. For the 2 kilograms, they have earned 12 points. For the 3 kilograms, they have earned 18 points. For the 4 kilograms, they have earned 24 points. And for the 5 kilograms, they have earned 30 points. Now, what can you notice about the number of kilograms of waste paper collected by the grade 9 class and the number of points they have earned upon collecting them? So notice that the number of kilograms increases because from 1, naging 2, naging 3, naging 4, naging 5. Now, what happened to the number of points? Does it also increase or it decreases? So, the number of points also increases because from 6, naging 12, naging 18, naging 24, naging 30. So, as the number of kilograms increases, the number of points also increases. Which means that this situation clearly illustrates an idea of direct variation between two quantities because, as said gani, the number of kilograms increases and the number of points also increases. Whatever happens to our first variable, which is the number of kilograms of waste paper collected by the grade 9 class, ang mananatabo sa atin yung second variable, which is the number of points they have earned. So, nag-increase. So, therefore, it is a direct variation. So the higher the number of kilograms, the higher the points to be earned. So try to look at this one. So upon collecting 1 kilogram, they have earned 6 points. Now how about kay collect sila ng 5 kilograms? They have earned 30 points, which is way higher than the 6 points they have earned. So the points vary directly to the number of kilograms, or points and number of kilograms illustrates direct variation. Let us have some exercises. Determine whether the given situations illustrate direct variation or not. Now, first, the number of hours you work and the amount of your paycheck. So, is this a situation illustrating direct variation or not? So what do you think will happen if the number of hours you work increases? Do you think the amount of your paycheck will also increase or it will decrease? If your answer is it will increase, then this is a situation illustrating direct variation, because as the number of hours you work increases, the amount of your paycheck also increases. But if your answer is it will decrease, then this is not a direct variation, because whatever happened to the first variable is the opposite of the second, or what happened to the second variable. So this is not direct variation. So what do you think is the answer? Is this a situation illustrating direct variation or not? So as the number of hours you work increases, of course, the number of your paycheck also increases. That is why some of us are relying on overtime duties. Because the more time you spend on working, the more money you get kung makasweldo ka mo. So, of course, this is an illustration of direct variation. So for the number 1, this is a direct variation. Second, the cost of filling up your car with gas and the number of gallons of gasoline that you are purchasing. So is this a situation illustrating direct variation? So what will happen if the cost of filling up your car with gas increases? Do you think the number of gallons of gasoline that you are purchasing also increases? Of course, it will increase. So the more money you spend on filling up your car with gas, the more number of gallons of gasolines you are purchasing. And likewise, if the cost of filling up your car with gas increases or decreases, the number of gallons of gasoline that you are purchasing are also decreasing, or also decreases. So for this one, this is a direct variation. Third, the time it takes you to get to school and the speed of the vehicle you are riding. So, does this illustrates direct variation or not? What do you think will happen if the time it takes you to get to school is shorter? So, do you think the speed of the vehicle you are riding is fast or is it slow? So, if the time it takes you to get to school is shorter, that means to say the speed of the vehicle you are riding is faster or fast. So that means to say the higher the speed, the lesser the time it will take you to get to school. Or the lesser the time it will take you to get to the school, the higher the speed of the vehicle you are riding. So it's opposite. One is decreasing, the other is increasing. As the time it takes you to get to school decreases, the speed increases. So they are opposite. That means to say this is a situation which is not illustrating direct variation. It does not illustrate direct variation, because as your time decreases, the speed increases. Or likewise, as the time increases, the speed decreases. They are opposite. So therefore, this is not direct variation. So this is one of those examples of the situations wherein it does not illustrate direct variations. Fourth, the number of mistakes in a test and the score based on the checks. So do you think this is an illustration of direct variation or not? So what will happen if the number of mistakes in a test is increasing? Kung taas ang number of mistakes mo, do you think the score is increasing or decreasing? Of course, if the number of mistakes in a test is increasing, the number of score based on the checks is decreasing. More mistakes, less score. Diba? Less number of checks. Or less mistakes, more ang score, or the greater the score is. So that means to say they are opposite. So this situation does not illustrate direct variation because they are opposite. So kung mas rako ang sala mo, mas gamay imo nga score. Mas gamay ang sala mo, mas rako imo nga score. Or mas hanggod. The term is hanggod. Mas hanggod imo nga score. Okay? So this is not direct variation. Okay? Next, the number of workers and the number of days it will take them to finish a certain job. So do you think this is a situation that illustrates direct variation? So what will happen if the number of workers is increasing? So kung more workers, anong nakatapos sa number of days it will take them to finish a certain job? So as the number of workers increases, the time it takes or the number of days it will take them to finish a certain job decreases. Syempre, more workers, less work. So mas dasig matapos. Okay? So the number of days it will take them. We are not talking about the speed, but we are talking about the number of days it will take them to finish the certain job. So mas rakong workers, mas gamay ang number of days nga matapos na ang isa ka obra. So if we have 5 workers and it will take them 3 days to finish a job, kung dugangan mo ra, may mo be 7 workers, of course, it will take them less than 3 days to finish that particular job because mas rako sanda nga ma-share sa obra. So that means to say the number of workers is not directly proportional to the number of days it will take them to finish a certain job. So this is not an illustration of direct variation. Now let us have the second type of variation, the inverse variation. Inverse variation occurs whenever a situation produces pairs of numbers whose product is constant. So for two quantities x and y, an increase in x causes a decrease in y or vice versa. So this is different from the direct variation because here in inverse variation, as the x variable increases, the y variable decreases. So they are opposite. So whatever happens to the first variable, it's the opposite sa second variable. So that is for your inverse variation. Now, there are situations in real life that illustrates an inverse variation. Take this as an instance. Do you know that an increasing demand for paper contributes to the destruction of trees from which papers are made? If waste papers were recycled regularly, it will help prevent the cutting down of trees, global warming, and other adverse effects that would destroy the environment. Paper recycling does not only save the earth, but also contributes to the economy of the country and to the increase of income of some individual. Now, this situation clearly illustrates an idea of inverse variation between two quantities. We are talking about here the demand for paper and the number of living trees. They illustrate inverse variation because as we demand more papers, then more trees will be cut. That means to say less living trees we will have less living trees. So the higher the demand for paper, the lesser the number of trees. So the demand for paper varies inversely to the number of trees, or the demand for paper and the number of trees illustrates inverse variation. Again, we are talking about here the demand for paper and the number of living trees. They illustrate a situation for direct variation. But if the case is we are talking about the demand for paper and the number of trees that will be cut, so that will surely illustrate direct variation because more paper means more trees to be cut. So that is direct variation. But again, we are talking about the demand for paper here and the number of living trees. Of course, if you will cut more trees, then there will be lesser trees that will be left. Okay? Now let us have some exercises. Determine whether the given situations illustrate inverse variation or not. So first, the number of apples and its total cost. So what do you think will happen if we increase the number of apples? Do you think the total cost will also increase or will it decrease? So of course, the more apples you will be buying, the more money you will be spending. So this situation illustrates direct variation because whatever happens or what happened to the first variable is the same as to the second variable. So this is not an illustration of an inverse variation. Kay inverse variation, it will be opposite always. But for direct variation, it will be the same. So as the number of apples increases, the total cost also increases. So this is a direct variation, not an inverse variation. Second, the number of persons sharing a pizza and the size of sliced pizza each one gets. So what do you think will happen if the number of persons sharing the pizza will increase? Will the size of the sliced pizza each one gets also increased, or will it decrease? Of course, the more persons sharing a pizza, the smaller the size of the sliced pizza each one gets. So this is an example of a situation illustrating inverse variation, because as the number of persons sharing the pizza increases, the size of the sliced pizza each one gets decreases. Third, the distance traveled by a jeepney and the time it takes to travel that particular distance. So we are talking about distance and the time traveled by the jeepney at a constant speed. So if a certain jeepney traveled 20 kilometers within 1 hour and then it traveled again 30 kilometers, do you think the time it will take to reach 30 kilometers will be greater or smaller, or will it be bigger or smaller than 1 hour? So of course, it will be bigger than 1 hour. Kaya 20 kilometers, 1 hour na rin din travel. That means to say, if nag 30 kilometers pa kita na, the jeepney will be spending more than 1 hour to travel that particular distance. So the distance traveled by the jeepney increases, the time also increases. So this illustrates a direct variation. So this is not an inverse variation. And then fourth, how fast or slow a jeepney travels and the time it takes to travel a particular distance. So how fast or slow a jeepney is its speed. So speed is how fast or how slow a moving object is. So in this case, we are getting the relationship between the speed and the time traveled by the jeepney. So kung mas dasig ang padalagan sa jeepney, do you think the time it will take to travel a particular distance is shorter or mas longer or longer? Of course, kung mas dasig ang jeepney, mas gamay ang it-take na nga time to travel that particular distance. Pero kung kung slower ang jeepney, then it will take the more time to travel that particular distance. So the speed is increasing, the time is decreasing. Or if the speed is decreasing, the time is increasing. So they are opposite. So that means to say this situation illustrates an inverse variation. And then for the last one, the number of taps that can fill a tank and the time it takes those taps to fill that tank. So example, we are filling a tank with water. So if we increase the number of taps that can fill a tank, do you think the time it will take those taps to fill that tank will also increase, or will it decrease? So of course, the more taps we have to fill a tank, the lesser time it will take them to fill the tank. Mas rako, mas dasig, mabuta. So that means to say the number of hours will be decreasing. So as the number of taps increases, the time it takes to fill the tank will be decreasing. So they will be opposites. So that means to say this situation illustrates an inverse variation. So the third type of variation is the joint variation. Joint variation is closely the same with direct variation. Only the joint variation involves 3 or more variables. So the statement A varies jointly as B and C means A is equal to KBC or K is equal to A over BC, where K is the constant of variation. So we will be studying this one later. There are statements which composed of 3 or more variables that illustrates a joint variation. Take this one as an instance. The area of a triangle varies jointly as its base and its altitude or height. So in this situation, we are not just getting the relationship between the area of the triangle and the base, but as well as the altitude or the height. So the statement illustrates joint variation. It involves three variables, which are area, base, and altitude. So this is our triangle. This is the height or the altitude of our triangle, and this is the base. So the area of the triangle will be based on the height, the length of the height, and the base of our triangle. Now let us have some exercises. Determine whether the given situations illustrates joint variation or not. First, the volume of a rectangular box to its length, height, and width. So the formula in getting the volume of a particular rectangular object is equal to, or V is equal to L times height times width, or L times H times W. So that means to say that this situation is an illustration of your joint variation, because it is somewhat like direct variation, but only there are four variables which are involved: the volume, the length, the height, and the width. So this illustrates a joint variation. Next, the circumference of a circle to its radius. So C is equal to 2 pi r. So how many variables do you see in this formula? So there are only two variables in this formula: the C, which is the circumference, and the R, which is the radius. This one is not a variable, but rather this is a pi. So a pi has a value which is approximately equal to 3.1416 or 3.1416. So that means to say this is not a variable, because variable usually has a variation of values. But for this pi, there is a particular value for that. But it is an irrational number. So that means to say it is non-terminating, it is non-repeating. So, but pi is not a variable, so we cannot count pi. So that means to say this formula is not an illustration of joint variation, but rather a direct variation. So for this number 2, this is not a joint variation. Third, the kinetic energy of a moving object to its mass and speed. So the formula for getting the kinetic energy of a certain moving object is Ke is equal to 1/2 mv squared. So Ke here is our kinetic energy, our m is the mass, and our v squared will be the speed or the velocity of our moving object. So this is an illustration of a joint variation, because as you may notice, we have here three variables involved: our Ke, which is the kinetic energy, our m, which is the mass, and our speed, which is the v, or our velocity. So again, this situation illustrates joint variation. And then we have here number 4, we have the force applied to an object to its mass and acceleration. So force is equal to the mass times the acceleration. So this is an example of our joint variation, because we have here three variables which are involved: the force, the mass, and the acceleration. So again, this one is a joint variation, or this illustrates a joint variation. And then lastly, we have the perimeter of a field to its length and width. So perimeter is equal to 2 length plus 2 width. So although we have here variables, three variables involved, but there is no common ratio for this, because we have here the formula isn't multiplication but rather an addition. So there is no common ratio for this one. So that means to say this illustration or this situation does not illustrate a joint variation. Let us proceed with the last variation, the combined variation. Combined variation is another variation involving physical relationship among variables. This is the kind of variation that involves both the direct and inverse variation. Again, this is the combination of the direct and inverse variation. So let us have an example. The force of attraction F of a body varies directly as its mass m and inversely as the square of the distance d from the body. So this statement illustrates combined variation because we have here first the direct variation. So F varies directly as m, or the mass. And we have also the inverse variation because your F, or your force, varies inversely as the square of the distance from the body. So the statement illustrates combined variation. So it is composed of direct and inverse variation. Let's have some exercises. Determine whether the given situations illustrate combined variation or not. First, the electrical resistance R of a wire varies directly as its length L and inversely as the square of its diameter D. So this illustrates a combined variation because there is the presence of direct variation and as well as inverse variation. Now, for the second one, the number of persons sharing a pie to the number of slices of the pie. Now, remember, as the number of persons sharing the pie increases, the number of slices of the pie, of course, also increases. This is different as to the first example or the other example that we have. Kagina size, this one, number of slices. So, kung madugang kita sang taho nga ma-share sa pie, then we will have more slices of pie, of course. So this situation illustrates a direct variation because as the number of persons sharing a pie increases, the number of slices also increases. So this is not a combined variation, but rather just a direct variation. There is no inverse variation. Third, the acceleration a of a moving object varies directly as the distance d it travels and inversely as the square of the time t it travels. So there is the presence of the direct variation and as well as the inverse variation. So of course, this illustration or this situation is an illustration of combined variation. And then, next one, the number of hours to finish a job to the number of men working. So again, this is an example of your inverse variation because the number of hours to finish a job varies inversely as to the number of men working. Because if the number of hours to finish a job increases, the number of men decreases. Or likewise, if the number of hours to finish a job decreases, the number of men, that means to say, is increasing. So this is not a combined variation, but rather just an inverse variation. And then for the fifth one, the current varies directly as the electromotive force and inversely as the resistance. So there is the presence of the direct variation and inverse variation. So therefore, this is an example of a combined variation. Now let us move on to the next part of our quarter 2 week 1 of your math text for grade 9. We will be translating into variation statement a relationship between two given quantities. So let us start with the first variation, direct variation. So the statements y varies directly as x, y is directly proportional to x, and y is proportional to x may be translated mathematically as y is equal to kx, where k is the constant of variation. So this is our mathematical equation. So y varies directly as x is similar to y is equal to kx. This k is our constant of variation. So this is the number being multiplied to a particular variable to get the other variable. So you multiply your constant of variation to x to get our y. So for two quantities x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. So this is true to our direct variation. So let us have some examples. Express each of the following statements as a mathematical equation. A. The fare F of a passenger varies directly as the distance D of its destination. So F varies directly as D. So how do we put this one into mathematical equation? So we say F is equal to KD, where K is the constant of variation. So we put the first variable on the left side of our equation, and then on the right side of the equation, we put our constant of variation, which is always K, and together with the k is the second variable, which is d. So we say f is equal to kd, or f varies directly as d. Second, the area of a triangle is proportional to its height. So how do we write this one into mathematical equation? So we say again, A is equal to KH. So we put our first variable on the left side of our equation, and then on the right side we have our constant of variation together with our second variable, which is the H. And this one naman is just the formula in getting the constant of variation. So if we want to get the constant of variation, that is K is equal to area over the height of the triangle. And then third example, we have here, the table shows the points earned by grade 9 class for every number of kilograms of waste paper collected. This is the same as our first example a while ago. So for the first row, we have the number of kilograms, and for the second row, we have the number of points. So we have here 1, 2, 3, 4, 5 for the number of kilograms, and then 6, 12, 18, 24, and 30 for the number of points. Now, given the table of values, we will be checking if this is or this illustrates direct variation or not. So how do we do that? We need to check if there is a common ratio. Common ratio, that means to say common quotient. So if we divide this one by this one, so if we divide the points by the number of kilograms, dapat the same ta na all throughout. So what is 6 divided by 1? So we have 6. What is 12 divided by 2? That is 6. 18 divided by 3, that is 6. 24 divided by 4, that is 6. 30 divided by 5, that is 6. So the common ratio is 6. So there is a common ratio. That means to say this table of values illustrates a direct variation. Likewise, if we divide 1 by 6, that is 1/6. 2 divided by 12, so kung i-lowest term natin, that is also 1 over 6. 3 over 18 is 1/6. 4 over 24 is 1/6. 5 over 30 is also 1/6. So there is a common constant. So there is a there's a constant of variation which is equal to 1/6. So that means to say this table of values illustrates direct variation. So the points vary directly to the number of kilograms. So we say P is equal to Kn. So where K is the constant of variation. So there is that particular number which can which multiplied to our n to get the p or the value of our p. So in this particular values, we have 6. Our k here is equal to 6. If you multiply 1 to 6, or if we multiply 6 to 1, that is equal to 6. If we multiply 2 by 6, that is 12. 3 times 6, that's 18. 4 times 6, that's 24. 5 times 6, that's 30. Our constant of variation there is 6. But we are just trying to get the mathematical equation. So that would be P is equal to Kn. And then the graph shows the distance traveled and the time consumed. So we have here 0, 0. So the distance traveled is 0. So here we have the time, and here we have the distance. So the distance is 0 when the time is 0. Now when the time is 1, and that is perhaps 1 hour, then the distance traveled is 10. So that is 110. And then if the time is 2, then the distance traveled is 20. If the time is 3, perhaps 3 hours, then the distance traveled is 30. For 4 hours, that is 40. And then for 5 hours, that is 50. Now, what can you notice? Okay, so notice that as the time increases, our distance also increases. So this shows a direct variation, because as the time increases, the distance also increases, or likewise, as the distance increases, our time also increases. But how do we put this one into mathematical equation? Now, is there a number which can be multiplied to 1, 2, 3, 4, 5, and perhaps 6 to get 10, 20, 30, 40, 50, and 60? Okay, so it's 10. So our constant of variation is 10. But what is the mathematical equation? So our mathematical equation is d is equal to kt. So there is this number that when multiplied to the time, we will be getting the distance. So, and that is 10, right? So when we multiply 1 by 10, that is equal to 10. When we multiply 2 by 10, that is 20. When we multiply 3 by 10, that is 30. 4 by 10, that is 40. And 5 by 10, that is 50. So our constant of variation is equal to 10. And our equation is d is equal to kt. Now, let us have some exercise. Express each of the following statements as mathematical equation. First, the cost C of fish varies directly as its weight, W in kilograms. So how do we put this one, or how do we write this one into mathematical equation? So again, we have here the first variable is C. C is equal to, its weight is W. So we have C is equal to KW. So again, ang first nga variable will be put on the left side of the equation, and on the right side will be the constant of variation, which is the K, together with the second variable. So C is equal to our constant of variation times the weight, which is W. So C is equal to KW, or C varies directly as W. So again, K is the constant of variation, or the variation constant. Second, an employee's salary S varies directly as the number of days D he has to work. So again, this S, which is the first variable, will be placed on the left side of our equation. Then on the right side of our equation will be our constant of variation, with which is K, and our number of days, which is represented by letter D. So our equation will be S is equal to KT. And then for the third one, a school bus travels a distance of D kilometers in T hours. So we have here D is equal to KT, or distance is equal to K times your T, or time in hours. So that is for our direct variation. Now let us proceed with the inverse variation. So for two quantities x and y, an increase in x causes a decrease in y, or vice versa. We can say that y varies inversely as the other. In simple, y is equal to k over x. So unlike again na, we don't have the fraction. Here we have the fraction because we are dealing with inverse variation. So the first variable will be on the left side of the equation, and on the right side we will have a fraction. In the numerator, we have the k, or the constant of variation, which is k, and in the denominator, we have your second variable. So y is equal to k over x, or k is equal to x over y, where k again is the constant of variation. This formula is how we get our constant of variation, but this is still our main formula, which is the equation of the variation. So let us have some examples. Translate into variation statement the relationship between two quantities. So we have here our table of values. For the first row, we have time in hours, that is 1, 4/5, 2/3, 4 over 7, 1/2. And then we have here the speed in kilometers per hour, so that is 40, 50, 60, 70, 80. So the time traveled is 1 hour, so the speed of the car or the moving object perhaps is 40 kilometers per hour. If the time is 4/5, then the speed is 50. If the time is 2/3, then the speed is 60. If the time is 4 over 7, then then the speed is 70. If the time is 1/2, then the speed is 80. Now notice that the time in hours decreases. From 1 naging 4/5, naging 2/3, naging 4/7 until naging 1/2 na lang. But the speed increases from 40, naging 50, naging 60, naging 70, naging 80. So as the time decreases, the speed increases. Or likewise, as the time increases, the speed decreases. So this shows an inverse variation. So how do we put this one into mathematical equation? So we say t, which is the time, is equal to k over s, or your t varies inversely as your s. So our first variable is t, so that is on the left side. And then on the right side, we have our second variable, which is the speed in our denominator, and in the numerator, we have our constant of variation, which is the k. So our final answer here is t is equal to k over s. Now let us proceed with the second example. So example letter B. The number of petri plants, which is represented by the variable n, in a row varies inversely as the spaces, which is s invariable between them. So how do we translate this one into mathematical equation? So again, our first variable is n, so n will be on the left side of the equation. So on the right side of the equation will be a fraction. In the numerator, we have the k, and in the denominator, we have our second variable, which is the s. So our constant of variation, or the equation for our variation, is n is equal to k over s, wherein n is the number of petri and s is the space between them. And of course, our k here is the constant of variation. And then we have the letter C. So this is the use of your graph. So we have here, sa bottom, we have the width. And then dito sa ato niya, on the left side of your graph is the length. So if here is our graph, so if we have here, our width is 2. If the width is 2, our height is, or our length is 6. If the width is 3, then the height is 4, or the length is 4. If the width is 5, then our length is maybe mga 2.5 or lesser than that. So mga 2.3 or 2.4. So, and then if our width is 6, then our length is 2. If our width is maybe 8, then that would be 1.7 or 1.6 for our length. Now, what can you notice about the graph? What happened to our width? What happened to our length? Now, our width increases. So, from 1, naging 2, naging 3, naging 4, naging 5, naging 6, naging 7. Okay. What happened to the length? Does it also increase or it decreases? So, ang aton nga width here is 2, tapos ang aton length is 8, or 6 rather. Now, we increased our width. It became 3. But what happened to the length? It decreased because from 6 naging 4. And then, gin-increase pa gid nato ng aton width. Ginhimo nato ng binga 6. What happened to our length? Nag-decrease ruman tana because from 4 naging 2 na lang tana. So, as the width increases, the length decreases. So this shows an inverse variation. But how do we put this inverse variation, or this graph, into mathematical equation? So the width varies inversely as its length. So we say W is equal to K over L. So our first variable is W and our second variable is L. So W will be on the left side, and then on the right side we have, in the numerator, we have the constant of variation, and in the denominator we have our second variable, which is the L. So we say W is equal to K over L. Actually, pwede man balis ka doon. We can have our L here and our W here, as long as one variable will be on the left side and the other variable will be on the right side, but in the denominator, because what is in the numerator is our constant of variation, which is the K. So, pwede man dyan, L is equal to K over W. So, this will show you, or this will be a situation illustrating an inverse variation. Okay, let us have some exercises. So, translate the following variation statement into mathematical equation. So first, the number of persons n needed to do a job varies inversely as the number of days d to finish the job. So our first variable here is n. So this will be on the left side. Tapos on the right side, we will have our k or our constant of variation in the numerator and our second variable, which is the d on the or in the denominator. So we will have our equation to be d is equal to k over d. So tandaan nyo lang, sa inverse variation, there will be a fraction. Okay? So again, k is the constant of variation or variation constant. Now, next, we have the rate r at which a person types a certain manuscript varies inversely as the time t spent in typing. So we have our first variable r will be on the left side, our constant will be on the right side and in the numerator, and our second variable, which is t, will be in the denominator on the right side. So we will have our second equation to be r is equal to k over t. And then, last one, the cost C per person of renting a private resort varies inversely as the number n of persons sharing the rent. So our first variable is C, so C will be on the left side, and then this will be equal to k over our second variable, which is n. So C is equal to k over n. So that is the equation of our variation, and that is for our inverse variation. Now let us proceed with the next type of our variation, which is the joint variation. Now if y varies directly as the product of x and z, that is, if there is a constant k such that y is equal to kxz or k is equal to yxz, then y varies jointly as x and z. Again, this is similar to our direct variation, only there will be 3 or more variables involved. Now let us take the first example. So again, translate into variation statement the relationship between two quantities. So first, V varies jointly as L, W, and H. So the first variable will be on the left side. On the right side of the equation will be your constant of variation together with your other variables. So V varies jointly as L, W, and H will be written into mathematical equation as V equals K, L, W, H, or k is equal to v over LWH. This one is for the constant of variation, but we need this one. We are just getting the equation of our variation. So v is equal to k LWH. And your v must be in capital letter because on your given, your v is in capital letter. 2. The area A of a parallelogram varies jointly as the base B and altitude h. So again, our first variable will be on the left side. Our second and third variable will be on the right side together with our constant of variation. So A is equal to K, B, H. So this is our constant or the equation of our variation. And this one naman is just the equation for our constant of variation. If you want to get the value of our k or the constant of variation, then a divided by b over h. So it's just our first variable divided by the combination or the product of our second and third variable. And then, for the third example, the area A of a triangle varies jointly as the base and altitude h. So this is just the same as to the first one. So that will be A is equal to K BH, or K is equal to A over BH. So they are just the same. So I'm so sorry about that one. So we have only 2 examples for this variation. Okay, so let us have some exercises. Again, translate the following variation statement into mathematical equation. So first, the volume of a cylinder B varies jointly as its height h and the square of the radius. Now, take note of these words. We have here square of the radius r. So how do we square radius? Okay, so again, our first variable, which is v, will be put on the left side of the equation. On the right side will be our constant of variation k, and we have here our h plus the square of the radius. So our equation will be V is equal to K, our constant of variation, times the height times the square of the radius. So that is V is equal to KHR squared. So K again is the constant of variation or variation constant. Second, the force F applied to an object varies jointly as the mass m and the acceleration a. So again, F will be on the left side of the equation. So on the right side will be our K, which is the constant of variation, and our m, which is the mass, and our a, which is the acceleration. So we say F is equal to K dm or am. Okay, so F is equal to K am. So you can rearrange or you can exchange the order of our A and M because that is just multiplication, and we have this property of multiplication which is commutative property. So it states that whatever is the position or changing the position of the factors does not affect the product. So kung giuna to si A kaysa kay M, giuna to si M kaysa si A, that doesn't matter because the product will be the same. And then the area A of a triangle varies jointly as the base, B, and the altitude H. So this is still the same as to the other one or as to the second and third example. So A is equal to KBH. Now let us have the last variation, which is the combined variation. So the statement z varies directly as x and inversely as y means z is equal to kx over y. So notice that our first variable is on the left side of the equation. On the right side of the equation will be our constant of variation still in the numerator together with our variable which is directly proportional to our first variable. And then in the denominator will be our third variable which is inversely proportional to our first variable. So this is our z that is on the left side. Our x will be on the numerator together with the constant of variation, and in the denominator we have our third variable. Now let us have our examples. T varies directly as A and inversely as B. So T will be on the left side. So this will be equal to, so in the numerator, we will have our constant of variation, which is the K, and our variable, which is directly proportional to the first variable, which is A. So KA over our B or our third variable. So T varies directly as A and inversely as B is translated as T is equal to Ka over B in mathematical equation. And then Y varies directly as X and inversely as the square of Z. So Y will be on the left side, X will be in the numerator together with the K or the constant of variation. The square of Z or Z squared will be in the denominator. So Y is equal to Kx over Z squared. Then lastly, we have the electrical resistance R of a wire varies directly as its length, L, and inversely as the square of its diameter, D. So, again, the electrical resistance, which is R, will be on the left side of the equation. And on the right side, we have our length together with our K, or constant of variation, over the square of the diameter, or the square of D, which is D squared. So our equation is R is equal to KL over D squared. Now let us have some examples. So R varies jointly as S and T and inversely as U. So again, R will be on the left side. And then on the right side, we have K or our constant of variation together with S and T. And then in the denominator, we have our U. So our equation will be R is equal to KST over U, where K again is the constant of variation or variation constant. Next, P varies directly as the square of x and inversely as s. So P will be on the left side of the equation, and then the square of x or x squared will be together with the constant of variation. So they will be in the numerator, and then our s will be in the denominator. So p is equal to k x squared over s, and that is our mathematical equation. And then lastly, the electrical resistance R of a wire varies directly as its length and inversely as the square of its diameter d. So this is just the same as to our last example. So R is equal to KL over D squared. So that's the end of our lesson for variation. So Ma'am Fortuna will be discussing the problem solvings involving variations. So that is the most important part of our lesson for variations. So I do hope that you will watch the video that we will be sending or we will be posting on our GC. So that's it for today. See you again on our next video tutorial. Bye!